Welcome everyone. This is session number 6 of the 8 webinars that we are holding this year to help math leaders across the state develop and refine their math intervention structures within their culturally responsive multi-level system of support. I'm Sarah Sum, a Technical Assistance Coordinator from the Wisconsin RTI Center, and I will be facilitating today's session. I'm joined by my colleague Heidi Erstad, who will be working behind the scenes today to answer questions in the chat box as they come up. Ken Davis, the math consultant from the Department of Public Instruction, can't be with us, but we will be hearing from him today through the magic of technology. We're also going to be joined by a guest speaker. We will introduce her, Lori Williams, when we get to her section of the webinar. Again, this webinar is being recorded and will be made available on the RTI Center YouTube channel and website, along with all of the presentations and resources shared today. We will email you the link by tomorrow, letting you know that they have been posted. Today's webinar aligns with the items you see on the screen from the RTI Center's School-Wide Implementation Review, or the SIR. The SIR is a free online self-assessment for schools to gauge implementation of their culturally responsive multi-level system of support. You can find out more about this tool at our website or by contacting us. Each topic in the series comes from the recommendations in the Institute for the Educational Sciences Practice Guide for Assisting Students Struggling with Mathematics. In previous webinars, we've discussed the role of screening, motivational strategies, and intervention content. Today, we will be focusing in on fact fluency within an intervention. You can see that the future topic is progress monitoring, and the last webinar of the series will be held in May, where we will review the content, discuss next steps, and possibly build in time for statewide networking. For our students to be successful in mathematics, they must be able to see themselves as a doer of mathematics. As shown in a previous webinar, if you were to Google mathematician, the pictures that come up are typically of white males. When looking at stereotype threat and the impact that it has on our students, it is important to introduce you to an important mathematician from history. Emily Nerta was a German-Jewish mathematician known for her landmark contributions to abstract algebra and theoretical physics. Her enthusiasm for mathematics made her an effective teacher, often conducting classroom discussions in which she and her students would jointly explore some topic. Her students have recalled that she urged them on, challenged them to get their nails dirty, and really dug into underlying relationships to consider the problems from all possible angles. As a woman, she worked without pay at the universities, at times accepting pay from her students because the university wouldn't pay a woman. Her teaching came to an end with the advent of the Nazis in Germany. Within months, anti-Semitic policies spread through the country. She was formally notified she could no longer teach at the university. As a dedicated pacifist, it was later stated that her courage, her frankness, her unconcern about her own fate, her conciliatory spirit were in the midst of all the hatred and meanness, despair and sorrow surrounding them, a moral solace. For a while, she continued to meet informally with students and colleagues, inviting groups to her apartment despite the repercussions that could result. Nerter should be recognized for her contributions as a Jewish woman mathematician. As we move into today, we'd like to take a look at what the research says about delving into fact fluency in an intervention. Then we'll move into how it looks in practice with 2 guest speakers, and then we will finish up with resources, reflections, and an opportunity to ask questions. Fluency is critical for success in mathematics, yet research has found that many students with difficulties in mathematics are not fluent in such facts. Weak ability to retrieve facts is likely to impede understanding of concepts students encounter later on in mathematics with rational numbers, since teachers and techs often assume automatic retrieval of facts for that reason. It's recommended from the IES Practice Guide that about 10 minutes be devoted to building this proficiency during each intervention session. Acknowledging that time may be short, the IES then does recommend that at least a minimum of 5 minutes per session. But what does fact fluency really mean? Wherever the word fluently appears in a content standard, the word means quickly and accurately. It means more or less the same as when someone is said to be fluent in a foreign language. To be fluent is to flow. Fluent isn't halting, stumbling, or reversing oneself. A key aspect of fluency in this sense is that it's not something that happens all at once in a single grade, but requires attention to student understanding along the way. It is important to ensure that sufficient practice and extra support are provided at each grade to allow all students to meet the standards that call explicitly for fluency. There's been research done by Susan Jo Russell in 2000 that states fluency consists of 3 elements. The elements are efficiency, accuracy, and flexibility. Efficiency implies that children do not get bogged down in too many steps or lose track of the logic of the strategy. An efficient strategy is one that the student can carry out easily, keeping track of sub-problems and making use of intermediate results to solve the problem. When we look at accuracy, that depends on several aspects of the problem-solving process. Among them are careful recording, having knowledge of number facts, and other important number relationships, as well as being able to double-check their results. Flexibility requires the knowledge of more than one approach to solve a particular kind of problem, such as 2-digit multiplication. Students need to be flexible in order to choose an appropriate strategy for the numbers involved, and also be able to use one method to solve a problem and possibly another method to check the results. Teachers across the United States ask students to memorize multiplication facts and sometimes addition and subtraction facts too, usually because our curricular standards have specified that students need to be fluent with number. Research from Fosnot and Doak define fluency as knowing how a number can be composed and decomposed and using that information to be flexible and efficient with solving problems. Whether or not we believe that fluency requires more than the recall of math facts, research evidence points in one direction. The best way to develop fluency with numbers is to develop number sense and to work with numbers in different ways, not to blindly memorize without number sense. So fluency demands more of students than memorizing a single procedure. They need to understand why they are doing what they are doing and know when it is appropriate to use different methods. So now that we know a little bit about what fluency is, how do we help students to develop it? NCTM states that to develop procedural fluency, students need experience in integrating concepts and procedures and building on familiar procedures as they create their informal strategies and procedures. Students need opportunities to justify both informal strategies and commonly used procedures mathematically, to support and justify their choices of appropriate procedures, and to strengthen their understanding and skill through distributed practice. Procedural fluency builds from an initial exploration and discussion of number concepts to using informal reasoning strategies and the properties of operations to develop general methods for solving problems. Effective teaching practices provide experiences that help students to connect procedures with the underlying concepts and provide students the opportunities to rehearse or practice strategies and to justify their procedures. Practice should be brief, engaging, purposeful, and distributed. Too much practice too soon can be ineffective or lead to math anxiety. Analyzing students' procedures often can reveal insights and misunderstandings that help teachers in planning next steps for instruction. In the same way, specific worked examples can serve as a valuable instructional tool, allowing teachers to understand how students analyze why procedures work or don't work and consider what procedure might be most appropriate in a given situation. This chart shows a breakdown of the required fluencies in grades K through 5. Some of these fluency expectations are meant to be mental, others need paper and pencil. But for each of them, there should be no hesitation about how to proceed in getting the answer with accuracy. For example, in grade 3, the fluency expectation for adding and subtracting within 1,000 are expected to be completed with paper and pencil when needed. This next chart shows the required fluencies in grades 6 through 8. Students, again, should be efficient, accurate, and flexible when working with fluency within these standards. The high school standards do not set explicit expectations for fluency, but it's important in high school mathematics. For example, fluency in algebra can help students get past the need to manage computational details so they can observe structure and pattern in problems. Such fluency can also allow for smooth progression beyond the college and career readiness threshold towards readiness for further study in careers such as science, technology, engineering, and mathematics. So going back to the recommendation from the IES guide, let's take a look at how we can really carry out this practice. For students in kindergarten through grade 2, we should be explicitly teaching strategies for efficient counting to improve the retrieval of mathematics facts. Once students have strategies in place, we should be providing them at least 10 minutes per session of instruction to build that quick retrieval of basic arithmetic facts. Lastly, it's important that we teach students in grades 2 through 8 how to use their knowledge of properties such as commutative, associative, and distributive to derive facts in their head. So for students in kindergarten through grade 2, it's important that we make sure we are ensuring our instruction first be both explicit and systematic. In addition, we should be using visual representations to model the mathematics. For this age group, you want to make sure that you are using strategies such as counting up, using students' assets, which is building what they already know, and immersing them in the commutative property of addition. When building time in for students to work on a quick retrieval of basic facts, make sure you first build on the asset of the child. Again, that is capitalizing on what they already know. When looking at time to work on fluency within a mathematics intervention, it's imperative that we weave fluency into our current instruction. Fluency is not meant to be siloed. It should be part of a bigger context of mathematical concepts. One such effective instructional method is by employing the use of number talks within a classroom. A number talk is a short, ongoing daily routine that provides students with meaningful, ongoing practice with computation. A number talk is a powerful tool for helping students develop computational fluency because the expectation is that they will use number relationships and the structures of numbers to add, subtract, multiply, and divide. Number talks should be structured as short sessions alongside the ongoing math curriculum. It is important to keep them short. They're not intended to replace the curriculum. In fact, teachers really only need to spend about 5 to 10 minutes on number talks. Number talks are also most effective when used daily. In students in grades 2 through 8, we should be using their knowledge of the mathematical properties to solve complex facts, including multiplication and division. The researchers have found that by teaching the use of composition and decomposition and applying the distributive property to situations, students can increasingly learn how to quickly retrieve facts. For example, the problem of 17 times 9, students are reminded that 17 is composed of a 10 and a 7, something they already know. Then the problem is parsed into easier known problems such as 10 times 7 and 9 times 7 to accurately and efficiently solve the problem to which the final product is 133. Going back to your definition on fluency from the first slide, and after hearing more about fluency, I want you to think, is your school or district's definition of fluency aligned to what we've talked about today? We've spent some time looking at fluency, and it's important that as we move forward and go back to our schools and districts, we also identify what fluency is not. As we think about what it means to be fluent, it is helpful to parallel what it means to be fluent in literacy. As educators, we should mirror some of the effective practices that are essential in a literacy classroom. For example, in early grades, do we time how fast a child can recite the alphabet? No, that isn't best practice and would just create undue stress and anxiety for the child. In order to learn to be successful in literacy, students should have memorized the meanings of many different words. But no student would say that English is about the fast memorization and fast recall of words. This is because we learn words by using them in many different situations, talking, reading, and writing. English teachers do not give students hundreds of words to memorize, then test them under timed conditions. All subjects require the memorization of some facts, but mathematics is the only subject in which teachers believe they should be tested under timed conditions. Why do we treat mathematics this way? People will argue that mathematics is all about getting the correct answers, not interpretation or meaning. That is wrong. Math is about reasoning, thinking through, and sense-making. Fluency is not time tests, memorization, teaching in isolation. We must dispel the notion that to be good in math is to be fast in math. Joe Boller states that learning is a process that takes time and cannot be accelerated by methods that encourage speed at the expense of understanding. What do we value, speed or learning? On the screen are 2 additional resources you can access to read more about fluency. Both articles are accessible to you with the other materials that we've presented today. As we head into our featured presenters, I want you to think about how we can embed reasoning into mathematics while working with our students to become fluent in their mathematical thinking. So up next is how it looks in practice. The first presenter, the featured presenter, we're going to hear from Lori Williams, who's the District Math Specialist for the Manitowoc School District. After Lori, we'll be hearing from Ken Davis as he extends Lori's concepts to look at fluency at the secondary level. So we are going to just switch over to Lori.
Hey, can you see my screen, Sarah?
Yes, we can, Lori, and we can hear you perfectly. Thanks.
Wonderful. So, good morning, everybody. As Sarah said, I'm Lori Williams. This is my 28th year teaching in the Manitowoc Public Schools. I've worked as a 4th and 5th grade teacher, as an instructional coach, a gifted and talented program coordinator, and I am currently the K-12 math specialist here. What I'm sharing today are pieces of my Wisconsin Math Council annual conference presentations on developing fact fluency. The research comes from a variety of resources that are listed on the later slides, and the lesson ideas are things that I've tried with students myself, or I've modeled, or I've co-taught. Oh, I'm messing with slides here. Okay, I think it's important to remember that it's the quality of practice that students do rather than the quantity of drill that students do that makes a difference in how quickly they learn their facts and how long they are able to keep them in their memory. Oftentimes, I work with teachers who, especially with the older students, say things like, "Oh, you've got to work on your facts at home." Well, if students and their parents don't have the strategies that they need to develop fact fluency, if they did, honestly, I think most of them would have already done that. So they need to learn to practice the strategies rather than try to memorize 484 different facts using flashcards. Vandewall and Lovin, in teaching student-centered mathematics, describe the importance of students first being able to compose and decompose single-digit numbers before working on fact fluency. They also found that students need to have operation sense or truly understand what those operation symbols, the plus, the minus, the times, and the division symbols actually mean prior to working on fact fluency. The next slides give just a few examples of how to do and how to work on those composing and decomposing concepts. Flash, or putting a collection of items up for students to view for just a couple seconds and then taking it away, and then asking them how many they saw and how they saw them, is an activity that can be done in just a minute or two anytime during the day. It can be done with 10 frames like this one. So as you see that, do you see 5 and 2, or do you see 4 and 3? You can also do Flash with Rec and Recs, or some people call them math racks, or you can do it with activities such as this. where we have a small quantity of items, and you can show kids how that quantity can be split into two different parts in different ways. And they then use that knowledge later when they try to learn fact strategies like make a 10. For example, if 5 can be 3 and 2, then when I'm trying to add 8 and 5, I can break apart the 5 and make the problem 8 plus 2 plus 3. Specific problem-solving activities are also done in the primary grades to help these ideas develop. This type of problem-solving that you see here is one that you would think that most 3rd through 6th graders should be able to solve very quickly, be able to go down and list 10 and 0, 9 and 1, 8 and 2. But most of the time when I'm working with our struggling intermediate students, I give them a problem to split 12 things as many ways as they can, and they don't just know this. The next slide has an example from 5th grade. Lillian is one of the students I worked with last year, and the problem is to split the 12 sheep into the 2 pens. When I asked her if she could split them in a different way, so her first attempt was the 6 and 6, the next way was 2 groups of 3 in each pen, and then when I gave her a specific prompt, if you don't have to have the same number in each pen, how else could you arrange the 12 sheep into the 2 pens? Then she didn't even stay with 12, and she only used 11 tallies. In Manitowoc, we use First Steps in Mathematics program, which is similar to AVMR, and I know that we've heard about that in some of the other webinars. And we use that for both diagnosing the holes in student understanding as well as finding interventions to kind of fill those gaps. This idea of composing and decomposing numbers is probably the biggest gap that I find with our intermediate students. Additionally, in order to gain that fact fluency, students have to know what those operation symbols mean before they can use strategies to make sense of mastering facts. When students have an understanding of the operations in a variety of contexts, and this is from the Common Core, we can teach strategies that allow access to a number of facts at a time, rather than having students memorize all of the individual facts. For example, if students understand array representations for multiplication, then we use paired story problems to help them understand the commutative property of multiplication. So I would use a story problem such as, how many musicians are in the band if there are 3 rows of 5? What about if there's 5 rows of 3? Sandy Atkins, from Creating Ahas, often reminds us that we can teach students to comprehend what they are reading mathematically if we have them read the equations in a variety of ways. So rather than saying 3 times 4, we can say 3 bags of 4 plums, 3 rows with 4 musicians in each row, or 12 divided by 3 could be 12 shared into groups of 3. How many groups of 3 can we make out of 12 things? Or 12 shared into 3 groups, depending on the context. Teaching the properties of operations not only helps students master their facts with understanding, but it gives them access to important ideas that they need for algebra later. I'll share an example of this in just a little bit. Excuse me. When we teach strategies, then we have to allow the students to use them in ways that make sense to them. For example, since I started working with students who struggle developing fact fluency, I started to reflect on how I do my own calculations. I always do 7 plus 6 as 7 plus 3 plus 3, a go through 10 strategy. Yet many students like to do 6 plus 6 plus 1, which is a doubles plus 1 strategy. I'm not sure if I was even ever taught doubles plus strategies. but I do know that I never use them. I do know that I don't just recall every single fact either. Yet I've reconstructed these facts and practiced the strategy so often that it's very fluent for me. Students should have that opportunity to do that sense making and connecting as well. I have found that planning lessons where students construct those relationships through problem solving really helps them actually develop the strategies. And I've made this a core of how I begin my fact teaching, regardless of the age of the students or which operation we're working on. So before I show you a video of a lesson you can do with students, here's a couple of reminders. Brain research supports the findings that premature drill doesn't allow kids to connect new information to old information so that it actually stays in their memory. And the strategies, not the individual facts, are what need to be drilled and practiced. Here's a couple other reminders from the research. I like to point out the sixth don't. There's no reason for students to be held out of in-depth math learning or advanced topics because they appear to have little fact fluency. As you'll see, it's not that students have no math fact knowledge, but in fact they know many facts. Instead, we need to differentiate the core instruction while the facts receive some remedial attention. Older students who are still counting on their fingers often don't even believe that they can master the facts because they have been so unsuccessful for so long. So the first thing I try to do is give them hope that they will be able to do this if they give me just a little time and practice. So now I'm going to take you through the beginning of my providing hope lesson. Here's the resources that I've referenced. And as Sarah said, this PowerPoint has been posted. So here's my first hope lesson. And I'm going to start talking as though I'm talking to students rather than to adults. So regardless of which operation we're working on, there's 121 facts to learn, 0s through 10s. So how many of you think you know your zeros facts? See, if you do, you know 21 out of 121, and that's really a sixth of them. Do you know your times ones? Look, you know 40 out of 121. That's a third. Just for you teachers out there, think about this in time tests. This means that if I can go through and do these 40 facts really fast, I still actually have time to count on my fingers to do the other facts. So time tests have been shown to cause anxiety, and they don't really accurately measure fluency of all 121 facts. Back to talking to the kids. Do you know that it doesn't matter which order the numbers are in the multiplication problems? So really, you only have 45 facts in the light blue to learn because the others are the turnarounds. How many of you think you know most of the 2s? So really, you only have 36 facts to learn. What about the 10s? Look, if you know the 0s, the 1s, the 2s, and the 10s, you know 72 facts. You know over half of them. And you probably know some of the 5s, but we can learn the rest of them with just one strategy. And then you need one strategy for the 3s, one strategy for the 4s, one strategy for the 9s, and not the one with your fingers that somebody has shown you. You need a strategy for the 8s. So really, if you know those first 5 strategies, and I teach you 6 more strategies, you actually will know all 121 of your facts. So the next piece that I'm going to show you is a 6-minute video clip from a presentation that I did on fact fluency for Michelle Parks and some of the teachers at CISA 10. And what this shows is a story problem lesson that teaches facts through properties of operations.
First, which I know math expressions doesn't do, that holds on. So what I'm going to tell you, you have to decide. Maybe I don't want to teach the zero property first, but maybe I am going to teach it this way later. And I'm going to keep going with the math expressions. Maybe I'm going to flip-flop with 2 lessons. You're going to have to make that call on your own pacing. Okay, and I know that James Burnett, the author of that, that would be stepping stones. And he would not agree with me either. What I have found is with my 4th and 5th graders, and if I'm doing remedial work, this works really well. So in 3rd grade, if you want to follow the pacing in your book and go with that, then you've been successful with it. Okay, if I start with the zero property, and I know there's 121 facts, on this chart, then if I know the zero property, I know 21 of those already. So I already know a 6 of them. That's a big chunk off of it. Okay, and if I'm teaching it in 3rd grade, I do it with story problems. And I have everybody have a whiteboard. And I do it like this. I'm going to go shopping today. We're going to do some multiplication problems. This is not problem solving in that you have to figure out the operation. I'm telling you right now. It's a multiplication story problem. Okay? I want you to draw the picture on your board that goes with my story problems. And I want you to do it as quickly as you can so we can get through quite a few at the same time. Okay? And I've done this with 3rd graders on the carpet usually, rather than at their desk. But I don't know what kind of space you guys have. Okay? So we've got our board, and Mrs. Williams is going into the candy store. She's going to buy 3 boxes of candy. Each box of candy has 0 pieces of candy in it. How many pieces of candy did she buy? And they draw 3 empty rectangles. Tell me it's 0. Tell me that I'm looking smart. But that is what we find out, and then we write on the board. The multiplication sentence that would go with that is 3 groups of 0 is the same as 0 pieces of candy. Okay, so erase your boards. Here we go again. Here's the next story problem. Mrs. Williams went into the candy store. She bought 0 boxes of candy with 3 pieces of candy in each box. How many pieces of candy did she walk out with? Draw the boxes, erase them, and then they figure out that there's nothing on the picture. That there's 0 groups. Okay? So what multiplication sentence goes with that? 0 groups of 3 is the same as 0. That's a little tricky for some 3rd graders to actually wrap their heads around. 0 groups of 3. Okay? So then we do 3 or 4 more. And I do 0 groups of 5 and 6 groups of 0, and we make those. And pretty soon they look at me like, Jennifer, candy, Mrs. Williams? I said, what do you mean? It's always 0. Why is it always 0? But we have to get it in 3rd grade language. Why? 0 times something, or something times 0 is always 0. And they try, and it's hard to put that into language. If you don't have any groups, there really isn't anything there. Or if you have a whole bunch of piles, but there's nothing in each pile, and they have to get that language out. And what they actually understand then is the 0 property of multiplication. They haven't learned just 21 facts. They've learned something that's going to be true all the time. So once they figure that out, then I say, well, let's test it with a couple more. You draw a couple more pictures. We do 2 or 3 more. Usually the 3rd graders 2 of them. takes a little while, and then they say 0. So it's always a difficult. Well, then you write a sentence that you know the answer to that has 0 in it. 0 times something or something times 0. Everybody writes. They don't have to write a story problem. They just write a multiplication sentence. Then we go around and we share our 0 times 3, 10 times 0. We go around. And what's the sassy kid going to say? 100 times 0. And the sassier kid is going to say 1,000,000 times 0. And then you're going to get somebody who's watched enough TV to say infinity times 0. And they've seen those commercials on TV. And then they know the problem. And they know it's always going to be true. And that's what we want them to know. Because that transfers all the way up through algebra. We don't want them to know 21 facts. We want them to know the 0 property of multiplication. And understand it. So then we've taught that one. Okay, if I'm remediating for the 5th grade, I'll say, do you guys know the zeros? Nothing yes. Okay, so you know all of those.
Okay, so that gives you an example of how we can use story problems as part of our teaching of properties of operations and how we can use that as part of their strategies. So I'm going to give the screen back to Sarah.
Great. Thank you so much, Lori, for that. And what we're going to do now is we are just going to switch over, and we are going to now share Ken's presentation, who Ken cannot be with us today. However, he's going to be sharing that just via technology.
I'm Kenneth Davis, Mathematics Consultant with the Wisconsin Department of Public Instruction. For my portion of today's webinar, I would like to extend some of the concepts that were already talked about and look at how those same ideas cross over into secondary mathematics. In particular, I want to take a look at operations with fractions and strategies in helping students become fluent in algebra. As Lori already noted, a strategy is most useful to students when it is theirs and built on and connected to concepts and relationships they already own. This mindset also applies to helping students in upper elementary, middle, and high school. We can help students become more fluent at concepts by being currently taught by connecting them to past concepts. Let's take a look at this by looking at the concepts of operations with fractions and algebraic topics. From the IES Practice Guide, Developing Effective Fraction Instruction for Kindergarten through 8th grade, we find 5 recommendations for helping students become fluent at operations with fractions. Time does not permit us today to discuss all 5 of these recommendations. So for today's example, we're going to concentrate on recommendation number 3, helping students understand why procedures for computation with fractions make sense. I chose this one because too many times operations with fractions is taught and viewed by students as a set of procedures just simply to follow without any logic given. For example, the operation of dividing with fractions is sometimes talked about and viewed as yours is not to reason why, simply flip and multiply. If you want students to be fluent with operations with fractions, they will need to understand the reason behind those procedures that we're asking them to learn. To help students understand why procedures make sense, there are 4 guidelines for us to follow. Number 1, use models, numbered lines, and other visual representations to improve student understanding of formal computational procedures. Number 2, provide opportunities for students to use estimation to predict or judge the reasonableness of answers to problems involving computation with fractions. Number 3, address common misconceptions regarding computational procedures with fractions. And finally, number 4, present real-world context with plausible numbers for problems that involve computing with fractions. Let's look at how area models and other visual representations help students make sense of computations. When comparing fractions, a pictorial representation can help students to better understand how fractions with the same numerator can be compared. Here are models of 3/8 and 3/10. In relation to the same whole, tenths are smaller than eighths, so it makes logical sense that 3/10 would be smaller than 3/8. By showing this pictorial representation, students become fluent with the concept of comparing fractions with the same numerator, and the same logic can be applied when looking at the same denominator. The picture helps them to understand why we compare fractions with the same numerator and same denominator. We build procedural fluency by helping students understand the concept, to help students understand the reason behind the concept. The same can be said when adding fractions with unlike denominators. The common mistake the students make is they add both the numerator and the denominator together. Certain representations can help by providing visual clues to help students see the need for common denominators. Instead of beginning by teaching students procedural fluency by asking them to find common denominators, show them a representation of why it's necessary to have common denominators. In this example, the representation is used to help students visualize the process of multiplication. What's also important to note here is that the representation helps students understand that the 2/3 that they're multiplying represents 2/3 of a whole. Sometimes this is not mentioned in mathematical problems. And finally, here's how we can represent division with fractions. This particular representation helps students to understand how many fourths of a ribbon will fit into 1/2 of the ribbon. Teachers should consider the advantages and disadvantages of different representations for teaching procedures for computing with fractions. The key issue is whether the representation adequately reflects the computation process being taught. For intervention purposes, it may mean going back and showing students conceptually how operations on fractions work so that they better understand the procedure that they are being asked to apply. Now let's focus a little bit on algebra. Here are 3 recommendations from the IES Practice Guide for teaching strategies for improving algebra knowledge in middle and high school students. For our brief time today, we're going to focus in on recommendation number 3, teaching students to intentionally choose from alternative algebraic strategies when solving a problem. When we teach students to intentionally choose alternative algebraic strategies, we're talking about 3 different guidelines. The first one is teach students to recognize and generate strategies for solving problems. Number 2 is encourage students to articulate the reasoning behind their choice of strategies and the mathematical validity of their strategy when solving problems. And number 3, have students evaluate and compare different strategies for solving problems. Let's look at an example of solving an equation. On the left side, you see the conventional method for solving this equation. Most of the time, students are taught that their first step is to clear the parentheses first. Then they can subtract or add the same amount from both sides of the equation. And then the final step is always to divide or to multiply to isolate the variable. An alternative method would ask students to think about x plus 1 as being something, this whole body, where we are multiplying it by 3 to get 15. What that means is that whatever we're multiplying by 3 to be 15 must mean that that value must be 5. Hence, x plus 1 would be equal to 5, and then x must be 4. By having students look at an alternative, they can become fluent at solving an equation. Another example of a little bit more complex equation looks like this. Again, generally the same pattern is conventionally taught, where students are taught to clear parentheses, and then students are taught to add or subtract common terms from both sides of the equation, and then isolate the variable. In the alternative method given on the right side, again, we can think of x minus 2 as being something. And if we remove 3 of them from one side of the equation, and we also remove 3 of them for the other side of the equation, that means we have 4 of these things left over. And then it goes back similar to the problem that we just did, where we have 4 of these somethings that are equal to 16. That means that each one of them must be equal to 4. Again, we can build fluency in students by having them look at alternative methods for solving instead of just one conventional way to solve a particular problem, or in this case, a particular equation. And sometimes equations aren't even necessary in order to solve a situation. Here's a situation where we're trying to determine the tax and tip that's given on a bill of $16. On the left side, we see a conventional way of solving this. On the right side, we see if a student can logically think through this problem and think that 10% of 16 is $1.60 and half of that is 80, therefore my tip must be $2.40. So I simply add the $2.40 onto my bill, and that would give me the total amount that was due. In both cases, dealing with computations with fractions and solving algebraic problems, too much attention is given to memorizing an algorithm as a means of achieving fluency, as opposed to teaching students strategies for accomplishing a task or solving a problem. The strategy adds flexibility for the students, since most strategies are based on conceptual understanding of a mathematics concept. And most of those concepts can be connected to students' prior knowledge.
A couple of things before we move into the reflection and resources is I hope that you gained that after hearing Lori and Ken talk, that fluency is not something that will be and should be taught in isolation, that we should really be using systematic and explicit instruction to really show our students the visual representations of mathematics so that they can make connections. I hope also that you've realized the importance of discourse with students as they're learning. And as we go through and we talk about how do we teach fluency back in our districts, I would also like to urge you to see how can we marry that our content standards to the standards of mathematical practice, and how can we make that mathematics come alive for the students that we work with. A couple of resources. Again, the two articles are already listed in the materials. However, we do have some Session 6 Fact Fluency resources that will be shared with you once the webinar is posted. We're still adding to that resource list. As we close out today, I do want to let you know that the upcoming webinars are going to be on April 20th, and that's going to be on progress monitoring, as well as the last webinar of this year will be on May 17th. And that will just be a culmination of the other webinars talking about next steps, as well as possibly trying to build in some statewide networking for the online participants. So a huge thank you again to our guest presenters for the hours and the efforts that they put into preparing for today. So we do ask that as you exit the webinar, you will get a brief 2-question survey about today's webinar. We ask that you please complete that just as a way to thank our presenters and also to give us feedback for creating future webinars. We'll stay on for a few minutes to address any questions. If anybody has any questions for Heidi, myself, or Lori in particular, please feel free to put those into the chat box, and we will go about that way for answering the questions. Please feel free as you move forward and go back to your schools and districts to contact any of us for more information and to further along this dialogue, and you can see all of our names and emails on the screen. So before we get into the questions, I want you to have a great rest of your day, and thank you for your participation. And we'll stay on for a couple more minutes in case there are any questions in that chat box. Thank you so much.